clinical pathology TEM workflow from specimen acquisition through automated preparation and electron microscopy. So I am the supervisor of the EM lab at ARUP. ARUP is a national and academic reference laboratory in Salt Lake City, Utah. The electron microscopy lab, we process around 25 renal biopsies per week, about 1,300 per year. We also process skeletal and heart muscle, as well as liver, GI, and cilia samples included in those renal specimen. So the timeline for installation of the ASP-1000 was April 2022. We started consultation with Steve and his team from Microscopy Innovations. In August of 22, they installed the instrument in our lab. We began development of protocol, and in November of 22, we validated renal specimen to be processed in that instrument. In June of 23, we validated muscle samples as well. So we used to use and currently use BioWave for our other sample types that are not validated in the ASP. And so we use a standard protocol, glutaraldehyde, osmium, urinal acetate, ethanol, acetone, and then into an epoxy resin. And so the issues we had with a microwave is it requires a lot of hands-on processing time. So about 2.5 hours for 6 or 7 specimens per run. And it would take 2 people each time. So around 10 to 12 person hours of labor. It's also difficult because it takes up a decent sized footprint in our fume hood. And we are limited to about 6 or 7 samples per run. And there's also a danger of losing samples. So that question was asked, how do our reagents changed? And so we just use a transfer pipette to put reagent in and then take it out of just a microcentrifuge tube. So there's a danger of potentially pulling sample out as you're doing that. So the ASP setup is in the bottom right there, the computer with the pumping system, and then a liquid handler with a deck there. So just quickly, previous methods of processing. So manual method could be moving samples between different reagents, long periods of time, sitting in reagents, and the same issues with lots of manual time needed to complete this process. And so just a visualization of the total time with the box, and then manual time being the orange bar. So that would be a typical manual process there. And then auto processors can reduce the amount of manual time needed, but still take a long time as a total time. And then further reducing time needed, as well as tech time needed, is use of a microwave. But it's still, as I was saying, requires a lot of manual hands-on work to process the samples, as well as being limited in how many can be processed at the same time. So the ASP helps reduce both the manual time needed and the total time needed for processing, while at the same time increasing the number of samples that can be processed altogether. Finally, there's the MPrep visualization. So at ARUP, we designed a protocol for about 2.5 hours for a full 8-channel ASP run, with about an hour of person effort to set up and maintain the instrument throughout the run, where the microwave would take about 2.5 hours, so approximately the same time, but it would take many more person hours to get the run completed. So the ASP, as I kind of said before, is a liquid handler with an 8-channel specimen arm, a deck that can hold 6 different types of trays. We use a 12 trough tray for our processing. It includes a pumping system and then a computer that controls the whole thing. So just on the left here, you can see the 8 channels on the specimen arm with the barcoded capsules on there, and then just a layout of the whole thing there. Yeah, so 6 plates, you can have multiple different reagents, 96 wells or troughs. And so I just like to talk about the process that ARUP follows to use the ASP and just processing our samples daily. I'll just start this. So a typical day at ARUP in the EM lab, we receive between 4 and 14 renal cases, as well as um, muscle, nerve, or other case here and there. For renal cases, we usually get 1 to 2 18-gauge renal cores of varying length. They need to sit in glutaraldehyde for at least an hour after they're collected. And then as we receive them, they're entered into our laboratory information system. Once they get to the lab, we dissect them into smaller 1 to 3 millimeter sections, and then we put them in the ASP capsules, as you can see on the right-hand side. We use a silicone tray with just a little bit of glutaraldehyde to make sure that they're not exposed to air for too long while we're preparing the other samples. So as they arrive in the lab, they come packaged in these kits. The vial on the right here is our glutaraldehyde kit that we provide. We place the kit and our barcoded sample into a little tray, and then as we transfer them, they're double verified. So 2 techs are making sure that the patient information is maintained throughout. In this vial, you can see there's several cores in there. That's not a typical number of cores. That's a validation sample that was taken for us. As they're dissected, they're placed into the ASP screened capsules. And then we place a second barcoded capsule to maintain the specimen integrity and hold the samples in place as the ASP is working. We have also developed a protocol to run 2 different patients on the same channel. So we double stack those in order to just get higher throughput there. And as you saw on the previous slide, we have this silicone tray to help prepare the samples. So the ASP is set up with the 8-channel head, and then we can do single row or double row with barcodes on top to maintain specimen integrity. So we can get up to 8 samples on a single row and up to 16 on a double row with 64 or 128 actual pieces that will end up in blocks in each of those examples. So starting the ASP, you select your protocol, and then after you're adding your samples, you can start it, and I'll just give you an indication of what it looks like on the next one. So you load the samples on the head there, and then we have our trays in the background there, and we're filling our reagents and then pressing start. The ASP, so it gives you an entire layout. This is the ASP layout. So you select a protocol that you'd like to do, so single or double row, and then it gives you each of the steps and how many oscillations it'll go through and what's involved in each of the steps. And it also gives you the tray layout, so you can program it to say, to tell you what fixative you have or what wash you have, how much volume is required, and so on. It's just a zoomed in view there. For ours, we use 3 different trays. I'll go through that on the next slide. So in our initial tray, we have a blowout well where the glutaraldehyde is blown out, and then we have a fixative rinse, a fixed rinse with buffer to remove all the rest of the glutaraldehyde. Moves on to osmium, and then a water wash, followed by urinal acetate, and then 3 more water washes. And I've designed the program to stop, drop into the final well, aspirate, and then hold until we're ready so that we don't have the protocol continuing through with no reagents in the actual wells. So our second tray is our dehydration steps. So we start with a 50% ethanol and move up through 100%. And same thing at the end of each tray. So it just goes in, aspirates, and holds. And you can see it working as we're filling the tray here. And then finally, we have our acetone, and then 1-to-1 resin, 3-to-1 resin, and 100% resin in the tray there. Okay, so the ASP functions by the 8 wells hold the capsules drop into the reagent then is aspirated up to a certain volume, and then on top of that there's a mixing step, so the oscillations mix up to a certain volume and then back to the original volume a designated number of times. You can decide how much volume you want to push across the samples, what the speed of the volume or the speed of the change is, and how many times you want to do that. And then at the end of that oscillation step, it dispenses the remaining liquid into the trough. So when we're finished with our ASP protocol, we pull the samples off the sample channels, and then they are placed into our flat molds, 1 sample per block. We double verify each time the sample is moved from 1 container to another. After the samples are placed into blocks, they're placed into an oven overnight for approximately between 2 p.m. and 6 a.m. The next morning we come in, we pull our sample out of the oven and cut thick sections onto glass, barcoded glass slides at about 400 nanometers sections. The slides are tracked through our LIS as well as everything else. Then we take thin sections, at 100 nanometers with diamond knives. We take 3 grids from each block, 2 sections at opposing orientation, and we track that in an electronic grid box form. We are then moving to electron microscopy, where we take images of the grids. We typically take 20 images, more or less, if necessary. The images are placed onto our server, where pathologists can then go in and review the images. We also supply images to clients through a separate server where they can download or view images. So just a recap here between microwave and ASP. So the ASP allows us to process from acquisition of sample to resin curing in about 3 hours, or between 1 to 8 cases, 2.5 hours on the ASP, and then 3.5 hours between acquisition and curing for our larger caseloads with that 3-hour protocol. And it still maintains about a 1-hour effort, regardless of 1 to 8 or 9 to 16 cases. And then every prep is identical due to the automation. The microwave is a great tool if you don't have too many specimen, but it takes a lot of person hours and is limited to with the number of specimen. So our work is barcoded almost all the way through, so the specimen identity is maintained. So we receive it again in a kit, and then it moves through each stage. It either has a barcode or is double verified and has a a different accession number coding system that we use. Slides are barcoded, and then our electronic grid log. So just in summary again, we have ARUP is regulated by CAP and CLIA, and we're ISO certified. We've validated our renal and muscle tissue samples. We track all of our specimens through barcoding and other coding systems, and it takes about 24 hours between receipt and by the time we get images out to pathologists. The automation that the ASP-1000 provides lets us get through an entire acquisition to resin curings step in about 3 to 3.5 hours. 1 to about 128 specimen pieces, and then 1 to 16 cases, about 1 hour of person effort, and the automation of replication there. Consumes about 4 to 5 mils of reagent. Yeah, so either way, if it's 1 to 8 or more, same volume, with a microwave requiring more. And then references for anyone who's interested. And again, thank you to Steve Goodman for putting this all together, and thank you for your time.